Okay, now we're dealing with Chapter 5, Section 7, and then Section 8, which is operations of matrices. Okay, a matrix is a rectangular array of numbers that we put in brackets, such as this one, A, which has 9 numbers in it, B, which has 3 numbers in it, and C, they're just different shapes, but those are all arrays and/or matrices. Now, the order of a matrix, you just count the number of rows going across and the number of columns going down. So this is going to be a 3 across and 3 down. So it's a 3 by 3. B is going to be a 1 across and 3 down. So it's 1 by 3. C, okay, the rows is a 3, and then columns, there are 2. So it's rows by columns going across and then going down. And that's the order of the matrix. It's going to come in handy later on when we start typing things in our calculators. Okay, a row matrix only has one row. A column matrix only has one column. A square matrix is just that. It's square. It has either 4 numbers in it, which make a square, or 9 numbers in it, which make a square. Then the principal diagonal is going down, the diagonal from the top left to the bottom right. Now, matrices are equivalent if all the pieces match up. So if A has to be 1, W has to be 4, X has to be 2, B has to be -1, Y has to be 0, and C has to be 0, because those are the places that match up. So again, X is 2, Y is 0, and W is 4. And then the ABCs. A goes back to 1, B goes back to -1, and C goes back to 0. Now you can add and subtract matrices as long as they are the same size or the same order, and you just add the corresponding parts. So in this case, A plus B, you just take -1, add it to 2, 3, add it to -1, 2, add it to 5, 7, add it to 0, and so on, which makes 1, 2, 7, 7, because you're adding those, and then -4 and 1 is -3, -5 and -1 is -6. Now subtraction, same thing. You can change all the second ones and then add if you want to, or just subtract the corresponding parts. -1 minus 2, 3 minus -1 is 3 plus 1, 2 minus 5, 7 minus 0, -4 minus 1, and -5 plus 1, making that the final matrix. Okay, scalar multiplication. You can multiply by a constant, like 2a's. You're just going to double all the components, making it -2, +6, 4, 14, -8, and -10. Now you can multiply matrices. It's more complicated, and you can also use a calculator on this part. It will do it for you, but the actual row operations of A times B, you multiply going across the first matrix and going down the second. So it's -1 times 2, 3 times -1, and you add those together. So it's always going across and down, and you do that each time. So it's -1 times 4, 3 times 2, -1 times 0, the last one, and 3 times 3. And then when you combine all those, you get -1, 2, 9, 0, 0, 12. And again, you can type these in the calculator, and we'll show you how to do that. It speeds up the process, but this is by hand. Okay, suppose we had these two matrices, 2a plus b. If you double that, add it to 0, makes 2. Double that, add it to 1, makes 5. Double that, add it to -2 is -4. Double that, add it to 2, should be 2. Sorry. Okay, 3a's minus 2b's. And if you want to type in the calculator, you can. There's a matrix key. You have to key in the matrices. Then you can just type 3a minus 2b. Or you can triple this, which is 3 minus double that is 0, so it's 3. 3a is 6, negative 3 and 0. 2b, I doubled my b and then I just subtracted those. I got 3, 4, negative 1, negative 4. Okay, a squared plus ab. If you take a squared, you multiply a by itself, it should give you this. A times b, if you multiply 1 times 0, 2 times 2. And so forth. And when you combine those, I believe you get negative 3, 7, negative 1, negative 3. Again, you can use a calculator on these. And there is a chance with all this multiplication that I made a mistake someplace. So you can use a calculator on these. Okay, section 8, inverse matrices. If you multiply two inverses, you get identity. So are these inverses? Well, if you take a, 1 times 6, 2 times 2, excuse me, 1 times 0.6, and 2 times 0.2 makes which is 1. Negative 0.4 and positive 0.4 makes 0. Negative 0.6 and positive 0.6 makes 0. 0.4 and 0.6 makes 1. So that's the identity, so they are inverses. Now, if you're actually going to find the inverse, you can augment the matrix. Take the one you have and put the identity next to it, and then just take this one and change it into the identity, and what's going to happen on the right side is your inverse. So this is a 1, I need a 2 there. So if I double that and subtract, I'll get 1, 1, 1, 0, 0, 3, 2, 1. I need to turn this into a 1, so I divide, or take a third of it. Need to turn that into a 1, so I subtract the top minus the bottom. And so I get my 1 minus 2 thirds is 1 third, 1 third, 2 thirds, negative 1 third, and that's my inverse matrix. Again, you can take your calculator, type in your inverse, your matrix A, and just use the inverse key on it, and it will find the inverse matrix. If you'll type in second x inverse right below the math key, crawl over to edit on the right side, type in whatever your order is, push enter a bunch, and just type in the matrix. Then when you go back to your quit clear screen, you can just type in matrix A, hit the inverse key, and it will give you the inverse. For bigger matrices, you can use that to add, subtract, multiply, and whatever you need to do. Okay, now inverses are good because you can solve systems. Suppose you have this system right here. What you do is call A the matrix of the letters. X, Y is the matrix of your X's and Y's, and then B is your matrix of your answers. And so basically you now have A, X equals B, because it's the A matrix, which is the numbers. Your X, which is your X, Y's, equals your B matrix. So when you move the A over, X is going to equal, these cancel, X is going to equal A inverse B. So all you have to do is type in your A matrix, your B matrix, and then what you need is A inverse. Here's your A matrix, or A inverse matrix, and there's your B matrix. And when you do A inverse B, it comes out to be 1 and 3 as your answer. So A inverse B will give you the answer to a system.